Good morning. It's great to be part of the AusNOG event, and I'm excited to present you all the optical fundamental for IP expert, taking you all from the digital world to the analog transmission. We had a great session yesterday where Gaurav, Lincoln, and Rob talk about how optical network are very important to have a resilient network, to have more availability and transmit multiple terabits of capacity from one location to the other. Optical transmission is a very vast topic that revolves around physics and mathematics, but since we have only 30 minutes today, not 3 years or 4 years of master's or PhD, let's go through some optical basics and try to understand its business and also the operational benefit that it brings for the IP view. Looking at the agenda, let's try to understand what our IP optical convergence means. There's a lot of focus going around IP optical convergence. Let's try to understand its meaning and what are the benefits that it brings on board. Second, we will go through why we should care about optical network. In this topic, we will have more discussion on the functional component of the optical layer, what are the considerations, and more importantly, what benefit it brings on board. Then we would see how the optical technology have evolved over a period of time along with the coherent plugs. And finally, we'll touch base on a multi-layer management system, which is generally the bedrock for the optical convergence. Before going to the technical discussions, we have organized a small survey to access through this QR code. It will just take 2 minutes, and you get a chance to win the Ciena merchandise. So please do access the QR and provide your feedback to it. So going back to a technical discussion, as you know, a lot of focus is going around IP optical convergence. So let's try to understand what exactly it's mean and what it brings on board. Different people have different aspirations or trying to achieve different things from the IP optical convergence. Many are looking at automation of service management. Others are looking at simple operations. Since I get a simple plane of glass so that I can manage my service provisioning to the service management at different layers, ease of management. Multi-layer control plane. The control plane exists at different layers. Historically, they were not talking with each other. Let us see if they talk with each other, what benefit they brings on board. And finally, platform convergence. Can I get rid of some equipment from my network or some electronic from my network? And if I get rid of them, what benefit it brings on board? Many agencies have conducted various polls, and what we have understood is automation for service management is on priority number 1. Wanted to optimize service provisioning across different layers. A multi-layer control plane and single plane of glass holds the second priority for operators or ISPs. And finally, the platform convergence. It's more on the hardware side where I can have more sustainable network, reduce a little bit of inventory in my network. So to understand, let's have a look at the optical layer from an IP view. This is what we look generally when we see a diagram coming from an IP expert. 2 routers with gray interface going through the cloud, and the cloud represents the optical transmission network. Many would like to understand what this lights and mirror does to my data. And if I get the knowledge and see how this data is transferred over the optical line system, I could better optimize my end-to-end network. So let's have a quick view of the value proposition that optical layer brings on board with a very simple example before jumping to the detailed discussion on the functional component. Let's take 2 routers. They are connected with gray plug, 400 gig. And when we look at this link, the total capacity of the link is around 400 gig. And the distance that it could travel would be around tens of kilometers, not much. Taking one step ahead, if we replace those gray plugs with coherent plugs and do nothing else, just replace these plugs, either with QSFP-DD, QSFP28, the total capacity would still remain 400 gig. But there is small incremental value on the network. Based on the type of plugs that we use, whether they are equipped with embedded amplification or not, we would be able to achieve a distance right from 25 kilometers all the way to 100 kilometers. So there is a small incremental value when you go from the gray plug to the coherent plug. Taking one step ahead, let's add photonic line system to it. which comprises of multiplex, demultiplex, ROADMs, and amplifiers. The total capacity now we are seeing on the network is multifold. We go from 400 gig all the way to 25 to 30 terabit of capacity. And the distance it could travel would be around 500 to 1,500 kilometers, again, based on the type of coherent plugs that you use on your router. So going from a gray plug to the coherent plug, there is small incremental value, but when we add the photonic line system, we see a dramatic improvement in the capacity and the performance. So that's the value proposition optical layer brings on board. It helps us to maximize your capacity and the performance. Going back, looking at the functional component of the optical layer and what are their roles in the layer. Let's see what's beneath that cloud. A router with gray interface connects to an expounder in the optical line system. And the main role of this expounder is to aggregate the incoming data signal onto an OTN frame and send it across to the optical line system. The expounder comes in two variants, a transponder and muxpounder. A transponder is a device that maps the incoming client signal onto the wavelength directly. A 100 gig client is mapped to a 100 gig wavelength. A 400 gig client is mapped to a 400 gig wavelength. Whereas on the other side, muxpounder is a device with multiplex various client rates coming from your router onto a single wavelength. A mix of 10 gig, 100 gig, 400 gig, and even 800 gig is mapped onto a 1.6 terabit of capacity. The muxpounders and transponders can be tuned to different frequency on the C band or the L band, and can be tuned to different line rates, right from 200 gig all the way to 1.6 terabit. So you don't have to run the transponder at the highest speed. You can run based on your requirement, based on the speed and reach that you need to achieve in the network. So when we talk about photonic network, we are talking about analog. And when the signal is transmitted over the photonic line system, there are a lot of linear and non-linear parameters that we need to take into consideration while planning the optical line system, as well as the capacity that we need to achieve on this network. So when we look at the performance parameter for a transponder, it depends upon the reach it needs to travel, depends upon the line rate that is tuned to it, and optical signal to noise ratio. These three are three key parameters to achieve the desired performance from a transponder. Else, you might need to regenerate your service, adding more electronics in the network that you take your TCO off the chart, with nowhere being to the sustainable goal of reducing the inventory. Taking one step ahead, multiplexers and demultiplexers, aka filters, is widely known as filters. So these are devices which aggregate multiple inputs, multiple wavelengths for different transponders, map it into signals, composite signal, transmit it over the optical line system, and at the far end, it demultiplexes those wavelengths and connects it back to the transponder. They come in different variants, right from passive 4-channel all the way to 96-channel to active colorless multiplexing and demultiplexing. If you need to amplify the optical signal or the transmission network, we need to amplify the optical signal. The amplifier nodes amplifies the optical signal and helps us to travel a longer distance in the network, taking you from metro all the way to long haul and submarine. Along with it also amplifies the optical noise. So it plays a very important role, amplifier plays a very important role when we are planning the optical line system. And we need to take into consideration how many amplifiers and at what distance we need to place an amplifier, and what would be the gain of the amplifier to achieve the desired performance and the capacity from the network. Taking ahead, the most important component in the optical line system are the ROADMs, reconfigurable add-drop multiplexers. As the name suggests, they are optical switch that helps us to steer the wavelength across different directions in the network with the help of the wavelength selection switch. And helps us to get rid of the expensive electrical interconnections in the network. ROADMs also helps us to balance the wavelengths, balance the power of different wavelengths in the line system, helping us to achieve an error-free transmission. So when we look at the hierarchical view of the network, the multiplexers, demultiplexers, ROADMs, and amplifiers forms the layer 0 photonic layer. On top of it, there are transponders, which forms layer 1 optical layer, service layer, through which optical services or wavelength services are running. And to these transponders and muxponders, coherent routers with gray optics are connected, forming data layer, transmitting layer 2 and layer 3 client and data services. So this is where the different components looks like in the optical network. And why should we care about optical network? This is a key point when we are talking about this topic in the AusNOG, where most of them are from the IP side of the world. It's because the decision that you make on your router port selection would impact your performance as well as the capacity that you're running on the network. When you talk about the photonic convergence, it's very easy. We just get rid of transponders and replace the gray plugs with the coherent plugs that goes onto the routers that are capable to insert a direct wavelength on the optical line system. But as I said, these selections would help you to have a better performance and achieve a higher capacity in the network. A couple of considerations are the form factors. We have different form factors right from QSFP-DD, OSFP, and CFP to DCO. Each form factor has its own pros and cons. And when you replace those plugs, gray plugs, with the coherent plugs on the router, it would impact your thermal efficiency also. So the operational expenditure need to be taken into consideration when we are finalizing on the optical plugs. Second are the line rates. This would have impact on your router port efficiency. So let's take a router with 4 ports of 400 gig, need to travel from location A to location C. And because of the impairments in the optical line system, we're not able to achieve the 400 gig line rate. So we are compensating on the router port efficiency, and this would have a direct impact on your capital expenditure. Going forward, if you're not able to achieve the line rate or the capacity that you need to achieve on the network, you might need to regenerate your service or might need to deploy a new fiber pair with new optical line system. And in both the scenarios, you're adding new electronics in the network that you take your TCO off the chart. And these are the 3 key parameters that we think from the business point of view need to be taken into consideration when you're moving from gray plug to the coherent plugs. From the operational point of view, the points to be taken into consideration is visualization, I would say. It's good to understand what's happening on the optical layer beneath my IP layer. And if I'm able to understand that, I would be able to create a holistic layer 0 to layer 3 infrastructure. On the second point is the service assurance. Layer 0, layer 1, layer 2, layer 3 have their own network alarms and performance monitoring parameter. If I'm able to understand what a layer 0 performance monitoring parameter would have an impact on my layer 3 services, and the correlation between different layers, would be able to provide better service assurance. And third and foremost thing is multi-layer control plane. Control plane exists in different layers, and they have their different mechanism of routing and path computation engine. When we talk about convergence, multi-layer awareness is very important. If my layer 3 is aware of what's happening at layer 0 level at a real time with the help of real fiber events and real-time latency, it could take a better decision. And this would help me to drive and create a service across multiple layers in the network. Going on the next topic of evolution of the optical technology. When you look at the optical line system, basically it was only C-band of 4,800 gigahertz that was widely used by the customers to deploy their capacity. And when they were exhausted, they used to deploy new fiber pair with new optical line system. With the advancement of L-band, with the seamless integration of C and L-band together, and most importantly, performance assurance, customers are now able to deploy L-band on the existing fiber asset, doubling their capacity. When we look at the component level, filters, which were generally 50 gigahertz and 100 gigahertz passive devices, with the component technology evolution and with the transponders, which can be tuned to different baud rate to meet region distance capacity, the MUX, TMUX, or the filters have also been evolved to support this varied channel width, enabling FlexiGrid. With the component technology evolution, we see improvement in performance. The insertion loss for this MUX, TMUX are getting reduced. We see improvement in the form factor, resulting in infrastructure saving in the network. When we look at the amplifier with the evolution in the optical technology, we see improvement in the optical power that would help us to drive longer distance. The convergence is not happening just on the IP optical level, it's happening on the optical line system also, on the amplifiers, on the ROADMs. Amplifiers are getting integrated with assurance components like OTDR, which would help us to give the real-time fiber events that could be communicated back to your layer 0 control plane to make better routing decision. We see form factor reduction. Amplifiers are getting integrated or getting added with C and L band amplifiers. They're getting added with bidirectional amplifiers, just simply helping us to reduce the TCO, overall TCO of the network. As we have seen, ROADMs played a very important role in the network, steering our wavelength, providing wavelength rerouting. We see integrations of C and L band amplifiers as well as OTDR in the same form factor, leading us to cost optimization. The way the ROADMs are deployed in the network nowadays with the help of the mesh, because of the mesh architectures, colorless, directionless architectures, they are providing more scalability to the network and act as an optical fabric for layer 0 control plane. So this evolution, integrations are helping us on the higher layers to have better service availability. Let us have an overview of how the coherent transponder have been evolved to coherent plug. But before that, let's see what are different components that helps us to build the coherent transponders. Talking about modulators or demodulators. Talking about lasers that helps us to tune to different frequency in C band and L band. A digital signal processor, which is the heart of the coherent transponders. Analog to digital converter and digital to analog converter. A transponder which is generally 300 mm high, 25 to 50 mm wide, and 300 mm depth, almost like an size of our laptop, a little bigger than the laptop, has now been miniaturized into a smaller coherent plug that can just fit in my palm, smaller than my palm. They have three variants, right from CFP2, OSFP, and QSFP-DD. And out of these three variants, QSFP-DD we are seeing is gaining a lot of traction in the market because of its form factor and the low thermal and power requirement. Many organizations like OIF, ITUT, and Open ROADMs are working on standardizing the line rate and forward error corrections so that this plug can interwork with each other and can help us to build the open network. It all started with 400 gig ZR, still in a lot of discussions, helping us to drive smaller spans, followed by ZR Plus, and ITUT and Open ROADMs are working on different modes to meet reach and capacity requirement. Vendors are also working on their specific proprietary mode called as performance optics that could be hosted on your routers or next-gen transponders, providing higher reach and more data rate in the network. Let's try to understand how these trends are going and how these different coherent plugs or the performance optics are adapted to different part of the network. Starting from the edge and the access. We see the architecture is very simple, point-to-point, hub and spoke, mostly in the data center side, with the physical infrastructure in the range of 100 to 120 kilometers. So in this form, in this network architecture, we see 400 gig ZR is gaining a lot of traction, just because it's very simple to integrate in your existing routers on the optical line system. Provides the optimized power consumption, and more importantly would help you to achieve the router port efficiency because the links are not too long, the fiber loss is not too high, so we could easily drive 400 gig on the 400 gig ZR plugs. Going towards the metro and the regional network. The architecture is basically hub and spoke and mesh architecture. With the physical infrastructure in the range of 100 all the way to 600 kilometers with varied fiber attenuation based on the type of fiber that you're using, how old, how many splices have been done to that fiber. This type of networks are equipped with ROADM for wavelength rerouting, for redundancy and resiliencies in the network. So ZR is not a good option here. We need to look forward for ZR Plus with forward error correction. The ZR Plus comes with two form factor, CFP2 and QSFP-DD. The challenge with QSFP-DD is that it has very low launch power. And to meet the complexity of the ROADM network, vendors are trying to add optical amplifiers into the ZR QSFP-DD optics. So one has to keep in mind, need to analyze it case by case basis when we are adding the ZR plug into the network when we're talking about metro and regional one. Going forward, let's look at the core side of the network where the architecture is linear, mesh. We're talking about distances right from 1,000 to all the way to 5,000 kilometers, covering metro, long haul, regional long haul, even submarine networks. And when we design this part of the network or select the components for this network, try to see how we can maximize the return of investment on our fiber asset, get more capacity from what we have deployed in the network. So for this part of the network, our recommendation would be transponder performance optics because that helps us to achieve more capacity per wavelength, right from 600 gig all the way to 800 gig, and also help us to provide assured performance in the network. So a performance optics with high capacity would drive more capacity per wavelength and help us to add lesser number of coherent optics in the network. So for the companies, it would be beneficial to attain their sustainability goal of reducing the inventory in the network. Going forward, going back to the initial question of what is IP optical convergence, and we see different people who are trying to achieve different things, and simplified operation or single plane of glass and seamless service management were the key points of consideration. That takes us to multi-layer management, which is actually the bedrock for convergence. Management layer exists at different layers, right from IP all the way to the optical, and they work in their own space. They don't know what's happening on the other side of the network. This is a very inefficient way of network designing, I would say, as we have seen in the past topic where multi-layer control plane, having the awareness of multiple layers, helped us to enable us to do routing and path computation engine very effectively. And that helped a really crucial part in the convergence part of this story. A multi-layer, a management layer having knowledge of multiple layers would really help us to do network discovery, proper network discovery, would help us to construct a holistic network view, would provide us a seamless integration of services across a different layer, and on the north-south interface could interact with the higher management, the OSS layer, with open interfaces like TAPI and IETF. So when we look at a controller, a management layer having knowledge of different layer, it would help us to provide better visibility of the network. Might be a 3D visualization of the network with different layers and how the services are flowing across different layers. Help us to do multi-layer network optimization, optimizing planning, ensuring router port efficiency. And also, importantly, on the multi-layer optimization work is interworking of multiple layers, multiple control plane. What if my layer 3 control plane is aware of the available resources on layer 0? It could make use of layer 0, which is known for its cost optimized redundancy and resiliency, instead of routing and path computation doing on the layer 3 level. And most importantly, a multi-layer assurance. If we know what are the alarms, if we understand the correlation, if we build a correlation between alarms across different layers, help us to provide better assurance to the customer. And at the end of the day, a single plane of glass managing the service or provisioning the service across different layers would enable us to have better service management capability, would help us to turn the service around very quickly, improving the customer experience. So this is what I have today to share with you on the optical side, and more importantly, why it is important for the IP optical convergence. I know the time was very less, and I was not able to complete a hell lot of physics and mathematics stuff, but if you need more information on the optical side, please do visit us on ciena.com or follow us on our social media. Don't forget to complete your 2-minute survey and get a chance to win your Ciena merchandise. That's all from my side. If you have any query, I'm happy to answer it. Else, wishing you a great day ahead. Yeah.